Let's talk about constructor, which is a concept that is no foreign to object-oriented programming languages, such as C++. C++ has a special class member function, a constructor that is called automatically when a variable of that class type is declared, and which can initialize data members. So you're looking at this C rectangle class. This C rectangle class has a constructor in yellow. This is what we call a user-defined constructor. The reason why this is user-defined it is because it's not default, and we'll talk about default in the next page. This user-defined has two arguments, right? And you have to supply this in order to instantiate this instance of C rectangle if you ever wanted to create an instance of it. So you can think of this constructor as a point of entry to instantiation, right? So before this class becomes an object, you would have to instantiate it. And of course, you can specify any user-defined constructors out there. And this is just one example, right? So let's look at the next page in more details. This very next one says, hey, we're going to create instance of the C rectangle. And the way that we do that on the stack is by issuing this with a semicolon at the end, right? So this is saying that, hey, we want to create an instance of this rect, and this variable name is rect, with a value of 3 and 4. And this is what we call a user-defined constructor. So if there is no constructor explicitly called or supplied to the program, right, by the programmer, the program will invoke the default constructor. So this is supplied to the code if you don't define it. This default constructor is used every single time, even if you don't explicitly call it. One thing about these constructors is you only call them once, meaning they are only executed once, right? When a new object of that class is created. So you can't just keep calling rect3, 4, keep on and off. So you gotta make sure this is only executed only once. This is a quick demo illustrating a default constructor here. We have a empty class called base. There's nothing in it. There's no default constructor. There is no user-defined constructor. There are no member variables, functions, and whatnot. However, we can declare an instance of it on the stack here, like so, and run it without an error. And the reason why this is the case is because before this instance of base or B is instantiated, the program actually supplies a default constructor that is called automatically by the program to instantiate this instance of a base on the class, on the stack. Now, we can also explicitly provide this default constructor like so. Gotta make sure that our constructor is actually public scope, right? So to do that, you specify a default constructor with the same name. This is not a function. This is a constructor that has no return type, right? So, and then with an empty declaration, there's nothing in it. And see if this works. And this works. Let's say if we don't make it into a public, right? Instead, we decided to do this. And by default, this default constructor will be of private scope. And that could be a problem because you want this constructor to be public. Okay, so that's one of the other things that you're gonna have to be careful of, and that is when you defined a constructor, you gotta make sure it's public. Sometimes people define their constructors in private settings, for the purpose of creating, for example, a singleton class, which is a design paradigm that is out of the scope for this demo. But yeah, I mean, this is one way to do it. And you can also specify, any custom constructors of your liking. And this custom or user-defined base constructor could also be, in this case, this would be a user-defined constructor. Okay. And then you can call it with an integer in it or something, but there is no implementations in here. It's just for illustrative purposes. So in this case, an instance of your base is created by passing an integer into user-defined constructor. So this allows you to create an instance of this base, right, in an alternative sense. So this default constructor is actually part of this, right, the very first one. Again, default constructor is something that is automatically supplied to the program if you don't specify it. So sometimes you don't, if there's nothing in there like this, there is nothing here, right? If a default constructor doesn't really have any implementation in it, you can simply just remove it. Not unless you have something in the implementation of a default constructors, then you would supply it to the program.